Hello everyone, we are Group 5 and we are going to present about the concept of magnetic force through electromagnetic suction experiment. We are from Group 5 and consists of 4 group members who are Koh Ming Keat, Wong Ying, Cheah Cai Fen and Muhammad Noor Arif bin Muhammad Azam. The objectives that we perform this experiment is to demonstrate electromagnetism. The experiment visually demonstrates the fundamental principle of electromagnetism, where an electric current through a wire generates a magnetic field. This is a foundational concept in physics and electrical engineering. Next is to understand solenoid function. By coiling the copper wire around the straw, the experiment creates a solenoid. This helps learners understand how solenoids work and how they can generate a uniform magnetic field within their coils. Moreover, to explore magnetic field effects, the movement of the needle towards the center of the solenoid illustrates how magnetic field can exert forces on ferromagnetic materials, leading to a deeper understanding of magnetic attraction and field gradients. Apart from that, to generate magnetic induction, the experiment can serve as an introduction to the concept of magnetic induction and how changing magnetic fields can induce motion in magnetic materials. Lastly, hands-on learning. It provides a practical, hands-on experience for students to engage with theoretical concepts, enhancing their understanding through direct observation and manipulation of materials. The electromagnetic suction experiment involving copper wire, straw, needle, and batteries is covered by several fundamental principles of electromagnetism. Here is a detailed explanation of the relevant formulas and law. Firstly, magnetic field of a solenoid, which is interconnected with the Ampere's law. Ampere's law relates the magnetic field around a current-carrying conductor to the current passing through it. For a solenoid, which is a coil of wire, this can be expressed as the formula below, where I is the electric current, B is the magnetic field, mu0 is the permeability of free space, and J is the current density. Next is the magnetic force on a ferromagnetic material. A ferromagnetic material like the steel needle placed in a non-uniform magnetic field experiences a force that moves it towards the region of higher magnetic field strength. This force can be understood using the concept of magnetic susceptibility and the interaction of magnetic dipoles with a magnetic field gradient. And it relates to the magnetic force formula as shown below, where F is the force on the magnetic dipole, M is the magnetic moment of the needle, B is the magnetic field, and nabla B represents the gradient of the magnetic field. Now, we would proceed to our experiment part. Before starting our experiment, we need a few materials, which are a needle, a 5-feet insulated copper wire, a drinking straw, and 2 3.7-volt batteries. To start our experiment, we need to coil the copper wire tightly around the plastic straw, making several turns. This forms a solenoid, essentially a coil of wire that generates a magnetic field when an electric current passes through it. Then, we need to leave a few inches of wire free at both ends after wrapping. After that, we need to strip the insulation from both ends of the copper wires using a stamp paper. This is because stripping the insulation exposes the copper core of the wire, which is necessary for making electrical connections. The conductive core is what actually carries the electrical current. Now, we connect the ends of copper wires to two 3.7 volt batteries. Then, we insert the needle partway in the straw and let go. Now, what happens? We can observe that the field attracted the needle just like a magnet and sucked it into the straw. This is because when we hook our solenoid up to a battery, the electric current flowed through the coils of the wire, which created a magnetic field. And this magnetic field attracted the needle just like a magnet and sucked it into the straw. Now, we perform our experiment in another angle for clearer illustration. Now, we would like to explain the experiment to the related laws and formulas. For the creation of the magnetic field, when the current flows through the copper wire wrapped around the straw, it generates a magnetic field inside and around the solenoid. According to Ampere's law, the strength of this magnetic field depends on the number of turns of the coil, the current, and the length of the solenoid. Next, the interaction with the needle. The steel needle, when placed inside the straw, becomes magnetized in the presence of magnetic field. The gradient of the magnetic field inside the solenoid creates a force on the needle, pulling it towards the center of the solenoid where magnetic field is strongest. For the movement of the needle, this movement of the needle towards the center demonstrates the concept of electromagnetic suction, where the magnetic field generated by the solenoid exerts a force on the magnetic needle, causing it to move. This is a practical demonstration of the principles derived from Ampere's law and the concept of magnetic forces. In conclusion, by understanding these laws and formulas, one can appreciate the underlying physics that drives the electromagnetic suction experiment, illustrating key concepts of electromagnetism in a tangible and observable way. And that's all from us, and thank you for listening.